everyone. I'm Mitchell. I build cool stuff at ThingMill. That's my Twitter, by the way. It's Mitchell Hamilton without the O, because my name's too long for Twitter, apparently. So at ThingMill, we do a lot of open source stuff, and one of those things is Emotion. I work on it a lot, sort of. And about 2.5 years ago, we had this problem. We had these two different APIs, one for just vanilla JavaScript and one for React. And we needed to figure out how to distribute them. And the obvious answer was, let's have two packages. But then we had another problem. One approach would be to have two repositories, one for each package. But this has a number of problems. First of all, it's got a really slow iteration cycle, because whenever we want to add a new feature, we have to go to one repo, make a change, go to another one, and keep on going. That takes a really long time. Second thing is dependency management is really hard across a ton of repos, because whenever you release a thing, you have to go to all the other ones and update them. And that takes a long time, and it's really error prone. And the last one is that we have a really split identity and documentation and issues. So if someone wants to find us, they have a bunch of repos they could go to rather than just a single place. And then that gets really confusing. Someone opens an issue, and we're like, oh, this should be over here, and it's all, what are we doing? So instead of having two repos, we could just have one. Or we could call it a monorepo. And this has a number of benefits. First of all, we can have PRs across multiple packages, so we can add all the new things in a single PR. The second thing is we have a single identity. People can go to one repo and find all of the stuff. And we also have centralized documentation and issues, so there's just one place to go for all the things. Except we have a big problem here. Monorepo tooling 3 years ago looked kind of like this. It worked, but it was kind of totally broken. So today I want to talk to you about some problems that we've found and how we've tried to solve them. So the first is dependency management. Second is packaging and releasing. So let's start with dependency management. So about 3 years ago, we were like, cool, let's use Lerna. That's the thing that everyone's using. So we just added a lerna.json, configured all the stuff, ran this bootstrap command, and cool, everything works, right? Sort of. So what Lerna Bootstrap does is it goes to all of your packages and runs npm install. And then it links all of the internal packages together with symlinks. But there's a big problem here, and that's that it runs npm install in every single one of your packages. So if we have 100 packages that depend on React, we have 100 copies of React, which is A, really slow to install, and B, in cases of packages like React, things are actually going to break, because React only wants a single copy. So some people at ThingMill and Atlassian built this thing called Bolt. Bolt tried to solve a lot of the problems of Lerna. Rather than doing a bunch of installs, it just did one at the root and then linked together all of the internal packages. And the way it did this is by enforcing a set of constraints. So the first one was that external package versions have to be equal. So if you have two packages that both depend on React, and they're at different versions, Bolt will go nope, you can't do that. So if you have a single version, everything's fine. Second one is that external packages have to also be in the root. So if one of your packages depends on React, you also have to depend on React at the root. And the third one is that internal package versions must be in range, which sounds super confusing. What it basically means is that you have one package that depends on another package in your repo. You have to depend on a version that will resolve to the one inside of your repo. And what this all means is that what Bolt can do is, rather than doing a bunch of installs, just one. And then it links together all the things. And that's cool. And then this thing called Yarn Workspaces came along. And it's like, hey, those Bolt constraints, nah, let's just not. Let's just do it all for you. Because sure, that'll be helpful, right? And it mostly is. So Yarn Workspaces is just oh, you have multiple packages that depend on React. Yeah, we'll just hoist them for you. No problem. Except there's actually a really big problem. If you depend on different versions of React, you'll still have multiple copies of React. So you have to rely on humans to fix it, and humans are human and do bad things. So what we realized through this is that constraints are actually really good. So we built a thing. It's called many-package. You can install it like this. And what it does is it's basically a linter for package.jsons in a monorepo. It'll enforce some of the constraints that Bold enforces, along with a bunch of other really, really useful rules. And we also have a fix command, so we can like fix all of your problems for you, or most of them. And what's really important about many packages constraints, as opposed to bolts, is that these constraints are actually solving people's problems. They're not solving technical limitations. They're solving problems that people actually have. So that's really awesome. So that's dependency management pretty much solved. I mean, mostly. So the second is packaging. So there are a bunch of things that you need to do to build an NPM package today. You want to have nice, consistent package.json fields, like with your like main and module and browser and all that stuff. You also want to bundle your code so it's smaller for users. And you want to use Babel because you want to use all the new stuff. And you want to have multiple entry points into the same package. And this is a really special and monorepo specific one. Because normally, outside of a monorepo, this will just work. But in a monorepo, it's actually kind of a big problem to be able to work on your project without having to constantly run a build script. And we've tried to solve that. So the first is you might have a package.json that looks like this. You've got like some weird names, and you're like the actual values of these don't matter, but having them all different is kind of confusing. So we built a thing. It's called preconstruct. You can install it like this. And then you run this init command, and it'll like ask you a ton of questions and get you nicely set up. And then if you want to like add stuff and like you broke stuff at some point, you can run this fix command, and it'll fix all of your package.json fields so they look really nice. So that's one problem solved. Now, bundling. So bundling is really hard. It's like a really hard problem that nobody wants to have to solve. But luckily, some cool people have solved it relatively well with Rollup. Rollup is a really great bundler, especially for libraries, because it's ridiculously good at tree shaking and making really, really small bundles. So we use it. We have a build command. It builds your stuff, because that's what you want. And we also want to compile with Babel. So we could just make preconstruct automatically configure Babel for you, and like that would be cool, because like it would just work, and that's all great. Except no, because different tools will have different defaults, and then that means you still have to configure it yourself, so you actually have consistent configuration across all of your tools, because then, a thing will compile with one tool, but then it'll break in another, and that sucks. So you might go, cool, I'll just create a Babel RC like I do in my repo, and it'll all just work, right? No, it won't. You have to use a babel.config.js or babel.config.json. Because weird Babel config resolution stuff that nobody wants to hear about. But basically, just use a babel.config.something, and you'll be good. So that's a lot of problems solved. Next is multiple entry points. So you might have seen packages like React DOM, where they have multiple things that you can import. You can import React DOM, or you can import React DOM/server. So if we go back to our diagram from before, we're actually missing something here. So we've got our repository and our packages. But there's actually a third concept we need to talk about, which is an entry point. Every single package will always have an entry point. Usually it'll just be one, but you can also have two, because there's a lot of cases when you want it. So preconstruct just lets you do that. You just specify the entry points that you want, and everything just works. And Rollup does the right thing, so everything's like you never execute the same code twice, and it's great. So that's most of our problems solved. Now we have developing without having to constantly rebuild, which is a really interesting one. So to run your code, you kind of need code to run. So since our package.jsons are pointing to files in our dist folder, if you don't have those dist files, your code won't run, because, yeah. So you might go, cool, I'll just, you go, cool, I'll just do a build. Yay. And like, you can do that. That works. And but you don't want to have to like run a command every time you make a change. So you go, cool, I'll just use a watch script. And like both these commands actually exist. You can run them if you want to, but they're both kind of not great because you still have to run this extra thing. Like you might be using jest. You don't want to have to start jest and this other thing, or next and this other thing. So we made another command. It's called preconstruct-dev. It'll create these dist files for you. But instead of being compiled code, they'll just re-export what's in your source files, so you never have to run another build script. So then you can require stuff, and it all just works. So that's more problem solved. Releasing. This is a really fun one. So we have a lot of constraints and important things that we want from the way we release stuff. The first thing is that we want contributors to declare their changes. So when someone makes a change, they should say what it is, like what should go in the changelog, what packages they want to release, and how they want to bump the version. We also don't want it to be based on Git commits. This is really important because things that are based on Git have a lot of problems. The first is that it's really hard to specify release info for multiple packages because like you have a commit and you could write like a long summary, but then like what's the format of that? And it's all really confusing. It also means that we have really, really strong opinions about how you use Git. And like people like squash and merge and rebasing and all that stuff, and having opinions about that kind of sucks. And the third thing is that if we want to update it, that's really hard. Like, yes, you can do it and you can do fancy Git stuff, but fancy Git stuff is hard. So, and if it's really hard, people probably won't do it. So people won't review change information, then you'll have worse change logs, and everyone's sad. So that's one requirement. We also want to bump dependent packages. So in a monorepo, if you have a package that depends on another package, whenever you release the dependency, you might also need to release the dependent package so that we still have that rule that many package enforces of all the packages must depend on other versions of the packages that are in the repo. We also want to be able to easily automate releases because maintainers have like 0 time. It's a massive problem. And the less time we can spend on releasing, the more time we can spend building cool stuff. So we built another thing. It's called changesets. You can install it like this. You run an init command. It says some cool stuff. And then you can create what we call a changeset. So you run this changeset command. It asks you what packages you would like to release. Then it asks you what semver version type you'd like to release it at. So like minor, major, or patch. Then it'll ask you to confirm. And then it'll generate a file that looks like this. So it's got 2 parts. The first is some YAML front matter, which specifies the packages that you're releasing and the bump type. And then below it, you just have whatever markdown you want. And this will go in the changelog. And then you run changeset version, and you're all good. So that's our first 2 problems solved. But we also need to do this bumping dependent packages thing. So let's say we have these 2 packages, which are like real packages that actually exist. We have Automotion/serialize and Automotion/react. And Automotion/react depends on Automotion/serialize. So let's say we want to bump Automotion/serialize with a major. So we bump it, yay, it's a new version. But we have a big problem here. We're still depending on the old version of Automotion/serialize. We don't want to do that. And luckily, changesets will just magically solve this for you. Just bump stuff so you don't have to worry about it. So that's that problem solved. Next is automating releases. So you can do it manually. You run version, then you commit that stuff, and then you run publish, and then you push all the stuff, and you're good. Like, that works. You can do it. But we really want to automate this. So the flow we have is that contributors create pull requests with changesets. Then our GitHub action will open a versioning PR, which looks like this. So it updates all the package.jsons, all of the change logs, and it gives you a nice summary of all the changes that you're releasing in the PR description. And then when you merge it, everything is published to npm. We'll create GitHub releases for you. And all you have to do is click a single button, and you're done. But what's really nice about this is that you still have to click that button. So you still have control over when you're releasing. You're not just constantly releasing, and then you have a million versions of everything. So those are our 3 big problems solved. Yay. So I want to talk about our benefits again. So we have like the 3 big things: having PRs across multiple packages, a nice consistent identity, and having centralized documentation and issues. But we solve these problems like really nicely, I think. And what that means is that it's a lot easier to have a monorepo. And so that means that we actually have more benefits now. So one thing is having simple imports. So who's ever had an import like this? Yeah, a lot of people. It sucks a lot. And they're like, I'm going to be really smart, and I'm going to do a Webpack thing. Has anyone ever done this? Like the Webpack thing? And then you like run your test, and like everything's broken, and then you like have to fix a bunch of stuff, and it all sucks. So what you can do is have a package. You can have a package. And what's really nice about this is you don't have to like configure every single tool, because this is just using Node's module resolution algorithm. It's just in your Node modules. It all just works for every tool everywhere. So that's one cool benefit. Another thing is that we have really strict API contracts. So have you ever like imported like a weird thing from some component? It's like not at all related to the thing you're building, but like it's the same as the thing you want, so you just import it, and then like the person who built that thing like wants to change it, and then like they can't because you're relying on it, and that just sucks. So if you're using a monorepo, it'll look a bit different because you'll like see source, and you'll go, OK, we should not merge this. Because you shouldn't go into source. And that's good because at least it's visible. But we still have the problem of you can still do it. As much as we can try and stop you, you can still do it. But luckily, not for long. There's this new thing, which is technically a node, but you shouldn't use it yet, called the exports field. And what it lets you do is specify what your package exports. So here, we're only exporting a thing from the root. And if you try and import anything else from the package, it'll just fail. That's the only thing you can import. So that's another awesome thing. Another thing is that we have this really nice structure with a monorepo, because each package is a thing. So if we go back to our button example. So we have our button. We have package.json. And this will have the name, the version, probably the license, dependencies, whatever. And it'll have a README, where it'll show you how you use this button and like how you install it, blah, blah, blah. And also a changelog to show what's changed and how you might migrate with major versions. And it's, of course, got the code that you actually need. And what's really great about this structure is that having a big, consistent structure across your repo lets you build tools on top of it. So we've, of course, got like many package and pre-construct and changesets. They're all really great. You should all use all of them. But this structure is especially really good for things like documentation. It's like, let's say every single package has to have a README. You can use that. Look through all the packages, find all the READMEs, display them on a website. Maybe also display the versions and the license and the changelog. And I think you can see where I'm going. And this is really just the start of what you can build on top of this structure. It's like, what else could you all build? So these are some really awesome benefits. And we've been learning a lot about monorepos at Thingmo. So we built a new website. It exists. You can go to it. Go to it. It looks great. Yeah, well, like, not now, but if you really want to. So it's got all of the knowledge that we've been building up over a couple of years now. It's got a getting started guide if you want to set up a monorepo with all the tools I mentioned. It's also got a document about like why you might want to use a monorepo, so you can understand why. Also, if you've read the Thinking in React page, this is a really similar idea about thinking in monorepos, because we've been seeing a lot of questions. They're like, how do I do this thing in a monorepo? Like, I know how to do it in a single package repo, but is a monorepo different? And this is trying to answer some of those questions. And if you really just want to jump in, we've got a starter repo. You can just clone it and get started. So yeah, that's monorepos. Thanks.